Okay guys, I want to talk to you a little bit about dilution. As I mentioned before, you can use molarity to calculate the dilution of a solution from one concentration to another. This is done by equating the molarity times volume of the initial solution to the molarity times the volume of the final solution. This is sometimes abbreviated by the equation M1V1 equals M2V2, or molarity and volume of 1 equals molarity and volume of 2. So to what volume should we dilute 0.2 liters of 0.050 molarity copper 2 phosphate to make a 0.001 molarity copper 2 phosphate solution? As I mentioned before, we can use the molarity and volume of the initial solution and equate it to the molarity and volume of the second solution. In this copper 2 phosphate solution, we have a molarity of 0.050 moles and a volume of 0.2 liters, and we want to convert it into a 0.001 molarity. To calculate for the volume of the final solution, we can divide the molarity and volume of the initial solution by the molarity of the second solution. In this case, the volume of the final copper 2 phosphate solution is 10 liters. However, remember that the final solution includes the 0.2 liters of the initial solution. Therefore, you must add 9.8 liters of solvent to the original 0.2 liters of copper 2 phosphate solution to create our final 0.001 molarity copper 2 phosphate solution. Let's go really quick to another problem. I want to find out what is the molarity of 1.2 milliliters of an initial solution of potassium chloride which has been diluted to 0.0105 molarity with a total volume of half a liter. Just like before, we use the M1V1 equals M2V2. In this case, we're trying to find out what the molarity was for the 1.2 milliliter potassium chloride solution, which was diluted to the 0.0105 molarity of the potassium chloride solution with a total volume of half a liter. Very quickly, I want to point out that I changed the volume values to liters. However, you could have used milliliters and get the same result. The main point is to ensure that both values have the same units with the correct values. So as you can see, the 0.0105 molarity of potassium chloride multiplied by the half a liter total can be divided by the 0.0012 liters of the original solution. This results in a 4.4 molarity sodium chloride solution. When you perform this calculation, you can see that the original molarity for a potassium chloride solution was 4.4. One last thing regarding M1V1. Remember that you can only use this equation when both solutions are of the same species. In other words, when you're diluting potassium chloride to potassium chloride, or when you're diluting copper phosphate to copper phosphate. However, if you attempt to dilute potassium chloride to potassium hydroxide, this equation will not be effective and you will get the wrong result. Okay guys, I hope that was useful for you. If you have any questions, please let me know.